Vector databases. Databases optimized for similarity search and AI embeddings. Vector databases are specialized databases designed to store, index, and query high-dimensional vector embeddings. They are optimized for similarity search operations and store data as mathematical vectors. These databases enable efficient nearest neighbor searches, making them a critical infrastructure for artificial intelligence applications. Here are some key concepts in vector databases. First, vector embeddings, which are numerical representations of data, such as text, images, and audio as high-dimensional vectors. These vectors capture semantic meaning and relationships within the data. Next, similarity search, which involves finding vectors that are closest to a query vector. Distance metrics like cosine similarity or Euclidean distance are used to determine the closeness. Dimensionality refers to the fact that vectors typically have hundreds or thousands of dimensions, representing complex features and relationships in the data. Finally, indexing algorithms, which are specialized techniques such as hierarchical navigable small world or inverted file index, organize vectors to enable efficient approximate nearest neighbor search. Let's look at how vector databases work. The first step is data embedding, where raw data is converted into vector embeddings using machine learning models, for example, transformers and convolutional neural networks. Next is vector indexing, which is organizing vectors using specialized indexing structures to enable efficient retrieval. Then similarity computation takes place, calculating distances between vectors using metrics like cosine similarity or Euclidean distance. The final step is approximate nearest neighbor search, which efficiently finds the most similar vectors to a query vector. Let's explore vector database indexing algorithms. First, hierarchical navigable small world graphs create a multi-layered structure of connections between vectors for efficient navigation. Hierarchical navigable small world offers fast search, excellent recall, but high memory usage. Next, inverted file index divides the vector space into clusters, allowing searches to focus only on the most relevant clusters. Inverted file index has lower memory usage, moderate speed, and good for large datasets. Product quantization compresses vectors by splitting them into smaller subvectors and quantizing each separately. Product quantization has very low memory usage and is scalable to billions of vectors. However, it involves lossy compression. Lastly, approximate nearest neighbors uses random projection trees to partition the vector space for efficient search. Approximate nearest neighbors is memory mappable and good for read-heavy workloads but has a static index. Vector databases use various distance metrics to measure similarity between vectors. Let's start with cosine similarity, which measures the cosine of the angle between vectors, focusing on orientation rather than magnitude, and the formula is cosine theta. Then we have Euclidean distance, which calculates the straight line distance between 2 points in Euclidean space, and the formula is square root of sigma of a minus bi squared. And finally, dot product, which is a simple multiplication and sum of corresponding elements in two vectors, and the formula is sigma of ai multiplied by bi. Here are some popular vector database solutions. Pinecone is a fully managed vector database with simple application programming interface integration and serverless architecture. It has real-time updates and hybrid search capabilities. Milvus is an open-source vector database designed for scalability and high-performance similarity search with cloud-native architecture. Weaviate is an open-source vector search engine with graph query language application programming interface and semantic search capabilities with multi-tenancy support. Chroma is an open-source embedding database designed for building large language model applications with Python-first application programming interface, local-first architecture, and optimized for retrieval-augmented generation workflows. Facebook AI Similarity Search is Facebook AI's library for efficient similarity search and clustering of dense vectors. Drant is a vector similarity search engine with extended filtering capabilities and cloud service with representational state transfer and Google Remote Procedure Call application programming interfaces. Vector databases have a wide range of use cases. Retrieval-augmented generation enhances large language models by retrieving relevant information from vector databases to provide context-aware responses. Semantic search is finding information based on meaning rather than keywords, enabling more intuitive and relevant search results. Image similarity is finding visually similar images by comparing their vector representations, useful for visual search and recommendation systems. Recommendation systems are suggesting products, content, or services based on similarity to items a user has previously engaged with or shown interest in. Fraud detection is identifying unusual patterns or behaviors by comparing transaction vectors to known fraudulent patterns in high-dimensional space. Genomic analysis is comparing genetic sequences by representing them as vectors, enabling rapid identification of similar genetic patterns across large data sets. Let's explore future trends in vector databases. First is multimodal embeddings, which will involve unified vector representations across text, images, audio, and video for cross-modal search and retrieval. Hardware acceleration. Specialized chips and processors optimized for vector operations and similarity search will become more common. Hybrid search systems. Combining vector search with traditional keyword search and structured data filtering will enhance search capabilities. Edge deployment. Vector databases running on edge devices for low-latency artificial intelligence applications will enable faster and more responsive artificial intelligence applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.